Hi everyone, my name is Ashlyn Posey and I will be presenting behavior monitoring techniques for killer whales. The problem with conducting research on killer whales is that they are aquatic and cover vast distances, constraining our ability to study their movements and behaviors. Let's start with photo identification. Variability in natural markings, such as the shape of the dorsal fin, pigmentations of the saddle patch, and scars on the dorsal fin, allow researchers to identify individual killer whales when they surface. Photo identification can be used in mark recapture models and is a good method for individual-based monitoring. Long-term photo ID datasets can be used to study life histories, population dynamics, long-term changes in social structure, and movement patterns. However, it is difficult to conduct in remote areas, and animals may be missed due to detection or availability bias. Whale watching vessels have also been shown to affect whale behaviors depending on the proximity. Next, let's move on to satellite telemetry. These tags can be used to monitor the movement of killer whales from remote areas. These tags often have several sensors that can record depth, stomach temperature, echolocation, and more. These can provide modeling at a large range scale and can provide information about an individual's location and behavior, including dive profiles and habitat information such as water temperature and salinity. On the downside, the amount of time or expense required to collect and process this data typically results in small sample sizes, and these tags are relatively invasive. Next, let's discuss acoustics. Acoustics can gather information on individuals or families present, their behavior, and social structures over a large area. Killer whales have three primary sounds: echolocation, clicks, whistles, and pulsed calls. These can be used to identify individuals and family groups and can provide information about presence on large spatial scales. This also only requires minimum fieldwork and can be deployed for up to 1 year. On the downside, the ocean has a lot of background noise which can affect the clarity of these calls, including sea state, biological noises, ship noise, and molecular turbulence. The last method I'm going to discuss is D-tags, or digital sound recording tags. These are a tracking device that records continuous time and depth, as well as a compass and acceleration sensors to record the three-dimensional movements. It also has two built-in hydrophones, allowing research to detect sounds produced and heard by an individual. This enables researchers to correlate vocal behavior with underwater movements and are attached using suction cups, so they are non-invasive. On the downside, these suction cups are more likely to become detached than typical satellite telemetry tags, and you must get close to the individual to place the cups. Of the methods I have discussed, I recommend using the D-tags over all other methods. D-tags combine acoustics and satellite telemetry into one device, allowing researchers to correlate movements and vocalizations in killer whales' behaviors, all the while being non-invasive compared to typical satellite telemetry methods. This technology can often have a lifetime of up to 1 month with an Argos transmitter, providing continuous recording. D-tags could be paired with photo identifications to confirm census data as well. To the left of my recommendations box, you can see an attached D-tag. My references are in the bottom right corner, and thank you all for listening. Feel free to leave comments or questions in the comments section below. Thank you.